Hey everybody, my name is Salah Issa. I'm an assistant professor at the University of Illinois Urbana-Champaign. Today we are going to be exploring the cause of injury or death in grain entrapments, engulfment, and extrications. To start out with, I have a bachelor's in biochemical engineering, a master's in ecological sciences engineering, and a PhD in agricultural engineering with a focus on agricultural safety. I've, I have a broad work experience where I've worked in developing consumer products, in biotech, in software, in government. And here at UIUC, my research focus is on injury prevention through predictive algorithms. Basically, the idea is predicting locations that are more likely to experience injuries, evaluating new technologies for safety before they get launched into the agricultural space, and then lastly, researching technologies that reduce or remove existing hazards from agriculture. So in this topic, we're focusing on basically what we call grain entrapments. Grain entrapments, it's a phenomena, it's a agricultural safety issue that occur mostly in grain bins, on farms, or in grain elevators. So what usually happens is that you have this grain bin where the farmer is emptying the grain. Due to crusting of the grain, either at the surface or somewhere inside the grain, you have this a big chunk that comes and basically clogs this auger at the very bottom. And then the farmer tends to go in with this long pole, and he uses this pole to basically crush that clump of grain. And so and while he's doing that, he's leaving the auger running so that he knows when he successfully removed the blockage. But what happens is sometimes the blockage gets removed and the farmer doesn't have the time to react, and he gets pulled into the grain mass. And if he gets partially pulled in, we call that grain entrapment. If it's fully pulled in, as you see in our second picture, we call that an engulfment. And also the process of rescuing the victim, we call that an extrication. And we tend to see this mostly in corn and soybeans and wheat. And while there's a lot of different types of grain entrapments, there's at least nine. The most common by far is flowing grain, which I just described to you right now. And about 70% of the incidents are basically flowing grain. So, in terms of grain entrapments, we've been seeing that as far as back as 60s and 70s. Really started in the 70s, but we have, I think, our earliest case was 1962 or 1964. And what brought this to really, in a sense, national attention, I would describe basically what occurred in 2010. We had four boys. They were sent into a grain bin, a huge, large grain bin, to walk the grain, walking the surface. Basically, what you do, you're walking it to crush the crust that we talked about earlier, so that it doesn't cause an issue later on. So these four boys were sent in to break the clumps of grain. They were aged from 14 to 19. Some have been on the job basically just a couple days or a week. So very new. They don't understand these hazards. They're very young men. And working in this grain bin, you end up in the scenario where basically two get engulfed in grain, one gets fully entrapped, one gets a bit entrapped, but he escapes and he calls attention for the rest. And this rescue takes all day, and at the end of it, uh, you end up with just basically you're rescuing the one individual, and you're recovering the bodies for two. And this was shocking because now that it's national attention, people started asking, well, how frequent is this? How frequently do these cases happen? What are the demographics? These are very young men to end up drowning in grain in a lot of cases, in a lot of dangerous industries. You can't have workers under the age of 18. And then what is the fatality rates of these incidents? So it starts basically, you start to get questions in a sense. And then we experience another case. This one happens in Iowa. This is just a 23-year-old man, again very young, and but in his case, he experienced asthma. So when he entered grain bins, knowing that it would be a very dusty operation, he wore basically a battery operated respirator, and he had a rope on him as well. And he similarly he gets engulfed. This case, he gets engulfed for 5 hours under 2 feet of grain, and he survives. And not just that he survives, when they rescue him, they measure his heart rate, and it's extremely high. So that just brings up more questions on this phenomena. Basically, what is the blood flow, heart rate? How is that being impacted by the body by being entrapped? Is there enough oxygen to survive in a grain mass? And lastly, but not leastly, is there a difference on survival rate of if you're entrapped? So you're not fully, your grain reaches basically to your shoulders, maybe less or so, or if you're fully engulfed. The next, then we see a case in Texas. In Texas, they wore the safety recommend what we recommend. They wore a harness. They had a safety line, and they had tied it to basically a self-retracting line, which, in a sense, if you're falling, it tends to clamp down to stop you. It's used a lot in construction industry. And but in this case, it did not survive. It did not help him. He kept, when he started drowning, he kept drowning. It never activated, and he ended up getting fully engulfed in grain. So that leads us to a question of, well, we have this safety recommendation of using harnesses. Are they effective? And what data do we know about that? Then, he was pulled with such force. We're wondering now, what are the extrication forces? Extract Like, how much force is the grain acting upon him? And also, what is, in terms of our incidents where they're dying, what is causing the death? Is it the lack of oxygen? Is it the amount of force on the body? So we're generating all these questions as we keep exploring these incidents. And we have a report that was published by Backelman, where they followed basically a report, and they went into the scene of an old man entrapped to his chest. And he was entrapped in basically 0 Celsius grain, very cold grain. And he previously had heart issues. And so anytime the rescuers tied a rope around him, and anytime they pull him up, he'd experience a lot of chest pain. They tried to give him medicine so that they could still pull him up. It didn't work. Anytime they tried to pull him up, he complained severely of chest pain. Finally, what they did is they basically put a barrel around him. They emptied all that grain around him, and finally, when they emptied out that grain, the pain was gone. So that also, in a sense, leads us to more questions. First of all, how does the temperature of the grain impact your chance of survival? When you're being pulled out of grain, doesn't matter how you're being pulled, doesn't matter where your limbs are. Uh, is that all contributing basically to, like, what is the being pulled from grain? What is it that causes so much pain in it? So that's all basically of these questions. And lastly, we have this case in California. It's a middle-aged man who's entrapped his chest in wheat, and he struggled to breathe while he was entrapped, and he kept complaining about that. They added a harness. They pulled him out of grain, and in a sense, they caused injury to his spinal legs. He stopped being able to walk for a while, and when he walks, he falls. He falls down, and also, in addition to that, he uh, he tended to, anytime he was in confined spaces, he tended to experience panic attacks. So that leads us to our last set of questions. how much pressure is on the chest that could impact your breathing, how much the spine, how much force can potentially handle if you're being pulled out of grain. What is the role of the type of grain? So again, this case was wheat, while all the other cases were corn before that. And lastly, what are the psychological impacts? So you get this very nice set of puzzles that we're trying to solve. We don't have the time and capacity to solve everything. So in a sense, everything here that we call it red, that is something that we use on the literature review to get just get start at least start developing answers towards that. Anything here in green, like harness use, entrapment, engulfments, the cause of death, we used the data that we've collected, the over 1,000 cases that we've collected, to have a better sense on what's going on here. And what remains here in blue, there's not a lot of data on that, so that's where we did some research. And I'm going to share with you my findings. Also, to make it easier, anytime you see a red puzzle figure on the top right, that means this was a literature method, literature results. And for literature, we've used Google Scholar. We've used basically this research was conducted at Purdue University. A lot of it, so we used their libraries in a sense, and we've looked at a lot of different terminologies such as suspension trauma, grain pressure, engulfment and extrication, vertical pull forces, and grain forces. And next thing is data, our database analysis. So at Purdue, they have the Agricultural Confined Space Incident Database, and they've been collecting cases since 1977. There's over 1,800 confined space cases. They've collected confined space cases from a lot of sources, from alerts, from news clipping services, from other databases, from personal interviews. And this database compiles that all together. So we've used that database to try to estimate survival rates, harness use, cause of deaths in both grain entrapments and engulfment cases. And lastly, for our experimental, so we ran, in a sense, 3 different experiments. The first experiment to the left is what we call the small-scale extrication. So in that small bucket, we put a lot of different grain types, and we put either a mannequin, a mini mannequin, or we put basically a cylinder, and we'll pull it out to see if there's a difference in grain types. In the middle experiment, we were analyzing the forces that were required to actually injure the spine. So we took lamb spine for that. And in the last experiment there, we have basically, in a sense, a box with 3 columns, 2 filled with grain and the one in the blank empty. So that we use to actually measure the pressure on the chest. And I'll expand upon that in a minute. So here's some of the designs for each one of these. So the small scale extrication, that's our container. And again, as I told you, we use the cylinder. See that in the first one, and we use the mannequin, and we place them in 2 different positions. Either he was straight or he stretched, because we were not sure if there's going to be a difference in forces. And these are the spines that we used. We obtained 9 segments from 3 lambs. And lastly, here, what you see in the third picture, that's for our chest experiment. So the column that's empty in the middle, you can see at the very bottom of it, there's 2 holes that have actually access to the grain mass. And you see in the top part, you have this block of wood. So that block of wood that acts kind of like a wall, so that grain does not flow from those holes into the middle surface. And what we did with the grain mass is that we press down. We had this long rod that we press down, and when it press down, it pushes those two blocks into the grain mass. And so in that sense, it can give us a measure of the pressure, like if you can imagine your chest basically expanding and pressing against the grain masses. We also did a large scale experiment. So we took a mannequin, a 180-pound mannequin, and we put him into our own constructed, basically, grain bin. And we'd fill this up, and we pulled him at different angles from 15 all the way to 75 degrees, because we wanted to get a better sense of what does how does being pulled at an angle impact uh, the the total force needed to pull out the victim. This becomes important because in a lot of cases there is not an anchor point straight up where a person got entrapped. So a person being entrapped, it's very likely they might get pulled at an angle if they get pulled. Okay, so let's talk about results. So in terms of our literature results, there were over 1,100 grain and crab entrapments since the 1960s. This data was up to date since 2017. Sorry, we've added another couple hundred cases since then. And majority of these cases are in the Midwest, vast majority of them, which makes sense because that's our corn belt tends to be in the Midwest as well. And what is surprising is about 28% of the incidents involve youth under the age of 21, and another 20% involve adults over the age of 60. So you're talking about 50% of the incidents involve either people who tend to be too young to be in the workforce, or just entering the workforce, or they're too old. They should be actually on their way out, retiring. Overall fatality rate is 67%. So 67% of these 1,100 cases were fatal. And one good news about that, I guess, in the last 5 years, the fatality rate was 42%. So in a sense, we're the efforts that we're doing to educate farmers on the dangers, it seems to be working a bit, but still 42%, that's really high. The overall fatality rate in agriculture in terms of incidents, so the number of fatal incidents divided by the number of injuries, is about 0.7%. And one thing we see in the literature and multiple reports is that extricating an individual vertically out requires about 4 times an individual weight. Okay, so um, looking at the environmental factors, the first thing we learn about is, in a sense, chest pressure. So when it comes to granule masses, there's actually two different pressures, and they matter. In water, it would be just one, whatever that pressure is at water, that's it. But in grain, it really matters whether the grain is pushing against the surface or the surface is pushing against the grain. So for example, you have your grain bin and you put your grain mass. The grain mass pushes against the the surface, right? And then you have this case of the human body. You're entrapped in grain. You're trying to breathe. Your chest is expanding. So your chest is pushing out against the grain. So when the grain is pushing against the surface, we call that active pressure. And when you're pushing against the grain, it's called passive pressure. And one way to get a quick sense of why there's two different pressure values, just imagine there's a box on an incline. The amount of force required to push it down is a lot less than trying to push it up. Because in one case, you're working with gravity, in the other case, you're working against gravity. And that concept is basically very similar. So that tells us that the previous measurements on the pressure in a bin might not be an accurate reflection of what a person experiences when he's entrapped in grain. And we'll cover that in more detail in the small experiment that we did. On top of that, we look at grain temperature. And first of all, grain can remain significantly cooler than outside temperature in a grain bin. It can be 10 degrees cooler because it has insulating properties. And you think of a person, if you put a person in water at 40 degrees, at 4 degrees, they can 4 degrees C, they can survive 30 to 90 minutes. Now here's the thing: is that we have to understand that this is due to conductivity, right? Water tends to be very conductive, 25 times more than air. Grain is only to 8 times more conductive than air. So we expect that a person who's entrapped at 4 degrees or 0 degrees in grain, it will basically their survival will be a lot longer, maybe 2 to 3 times longer than what we see in water. And lastly, most of our grains, looking at all of them, tend to be 40 to 60% oxygen. There, because you look at the masses, it's not a grain mass. It's not just solidly grain. There's all these holes and stuff like that, and those are 40 to 60% basically. So conceptually, there could be oxygen to breathe and survive long hours, but there's a lot more questions that need to be researched on that. Looking at psychological factors, there's an interesting study where if you put somebody in a harness and you pull up the harness and he stands still, he'll eventually actually faint. And that has to do with the blood flow and how the heart rate's responses when you're suspended in the harness. In another case, in another study they conducted, you're looking at boa constrictors. So boa constrictors, a lot of times they thought that the way they kill the victim is that they choke him. So they're attacking his chest, basically constricting his chest, and he can't breathe. But when they studied on mice, they realized that was not the case. Because it would take a lot longer for a victim to die. What the boa constrictor is doing is actually applying pressure against the body, impacting the blood flow and heart rate. And what happens in a lot of the boa constrictor, when it kills its prey, they die out of heart attacks, basically, more than, in a sense, being suffocated due to lack of oxygen. And that to me is very interesting because we have this massive brain, this massive pressure applied across the body when you're entrapped in grain. So it's not too surprising in the case of that man in Iowa, where he had very high blood pressure, very high blood rate when they pulled him out. Lastly, psychologically, there tends to be a fear of burial that's natural, and so that all might be impacting and might occurring when somebody gets entrapped in grain. Okay, looking at our data analysis, so we have found 570 of our cases tend to be entrapments, and 88% of these are fatal, and 210 cases are entrapments, so they're not fully under grain. And even in those cases, 70% are fatal. So that leads us to two questions. Why did those 12% survive in an engulfment? And then why did that 7% die in entrapment? Because your airways are clear. And looking at the cause of death, that's very rarely reported. 33 of our cases we had data on, and 64% was asphyxiation. Some of it was aspiration, some of it was crush asphyxiation. Basically, you can't move your chest to breathe. Then crushing, lack of oxygen tend to represent the other percentages. In terms of harness use and effectiveness, we don't have a lot of reports on harness use, though when we do, it tends to be more of a misuse than use. So, for example, the safety line was too long, contributed. Basically, if your safety line is too long, it's doing nothing to prevent you from getting entrapped. And we see that in a majority of our cases. And we see basically a lot of misuse. We've only seen 2 cases where they used the safety equipment properly, as we could deduce, and both of those were non-fatal. So in our small scale studies, so now we're looking at our experimental side, we tested it against different grains. So we have sunflower at one end all the way to corn on the other end. In addition, we tried corn at two different moisture contents levels so that we could get a sense, does it matter the grain moisture when if somebody is entrapped in grain? And so we find out that most of the grains tend to be not significantly different from each other, as with the exception of sunflower. And we noticed that when we used here we use like 22% moisture corn, tends to have a significant difference than basically dry corn in terms of amount of force required to pull the victim. And in terms of with the limb placement, if you remember correctly, we tried to pull him straight up or with his arms raised. We only saw that difference when he's basically engulfed in grain. So in our angle experiment, in our large scale experiment, you could see at the pull angle as we pull at more and more extreme angles that you see it actually increases in force. And this represents both corn and soybean, with the exception at the 15-degree angle, the soybeans did not increase while the corn still increased tremendously. And the maximum force we see is 4,400 newtons, which is a tremendous amount of force. And also when you pull at the vertical level at 90 degrees, that's not very different from other reports that were done before us. In terms of pulling the spine, so when we pull the spine, we heard a crack or basically the cartilage broke, really between 1,700 newtons to 2,500, which you compare with our earlier studies, that's similar to the average force to pull a victim if they were entrapped at shoulder depth was 2,300 and chest was 1,900, which tends to tell us don't try to extricate somebody by pulling them out because that force is similar between, for example, what experienced in breaking apart the spine and the force to pull them out. So there's a lot of danger in that, especially you don't know the condition of the person's spine or the health of that individual. In terms of our chest pressure, so this is just a graph of the force required when we're pushing against the grain. What we note is that what we notice is that if you're 10 centimeters under the grain mass, so which basically represents, like this much basically, you tend to experience 6 kilopascals. At 30 levels, you're experiencing basically 9 kilopascals. This compared to water, in water at that same level, you're experiencing basically 3 kilopascals. So you're talking that the pressure in grain is 2 to 3 times more than what you'd experience in water. And that's critical data to note because in other studies, when they're just looking at that pressure against basically an unmoving object where the grain is coming on, it tends to give you pressure similar to what you'd experience in water. And the question is, well, why? Why are they struggling to breathe? It makes no sense. Now we know it does make sense. It's because it's not about the grain mass on the body. It's your chest trying to push that grain mass out. That's what's causing the shortness in breath. Okay, so discussions quickly. So this is back to our puzzle, trying to figure this out. We came up with a lot of results. So now we have a better sense of the number of incidents. We're experiencing 20 to 40 incidents per year. And it's a pretty, and it's been pretty stable since then. We've seen entrapment versus engulfment. Entrapment is a lot, your survivalhood increases tremendously in comparison to engulfment. However, there is still risk of death in entrapment. Fatality rates overall are very high. About 2/3 of the cases that we have end up in a fatality, but it's also very dependent whether you're entrapped in or engulfed. We have a bit more understanding on the amount of force required to pull out a victim and how that it's it's large enough that it's comparable to the force that would actually hurt that spine. And there's still a lot of things we need to know about, for example, oxygen availability. We still don't have a sense on it. The blood flow and heart rate, we have a general sense that that it does impact and could be a cause of death, but we don't have enough data to. It's more anecdotal data at the moment, and that's so that leads us to uh, yeah. So these are basically the things that we could do more is looking at the blood flow, the oxygen availability, the chest pressure, and the condition type of grain. Uh, General recommendation: don't get entrapped in grain, and it comes and in a sense it's serious recommendation because you have to understand that 94% of all these grain entrapments are preventable based on what we looked at. It was operator error at some point of time that caused these entrapments. And in 6% of the cases where it's not preventable, you're talking about when basically maybe you had a structural collapse of the grain bin. That's not something you could anticipate on that same day, or you could wear basically PPE equipment to stay safe from that. One of the biggest, most important ways to keep a person safe is lockout, tag out. We had incidents where workers followed all the safety recommendations in terms of entering the grain bin, but they did not do a lockout tag out, and an unaware trucker would come in and he'd start emptying that hopper or grain bin, and it would engulf them all. Also, if you're a worker, when you're entrapped, if you get entrapped, do not get entrapped, first of all. But if it does happen, placing the arms and hands in front of the mouth and chest are critical because a lot of the incidents that we have where it's basically they're inhaling grain, which is ending up in their chests, in their lungs, sorry, and then also it's to reduce that pressure of the grain that's applying on your chest. And for rescuers, don't attempt to forcefully extricate the victim. And email me or let me know if you have questions. Thank you.